Hi everyone, welcome to Mrs. Caton's online science classes. Now, these are supposed to help you in terms of giving you a little bit of a reminder of what we've covered in class. It is by no means a complete class, but please feel free to view these videos over and over again so that you can remember a lot of the things that we've learned in class already. Now, we've already probably covered the periodic table in class, and we've covered the different groups, the different periods, the properties of metals, of nonmetals. These classes are really things that I can probably write on a board, and we're going to talk about the atomic mass and the atomic number and the calculations that are involved with it. So if you remember, we talked about the structure of an atom, and we said that the atom has a nucleus, and that nucleus has protons and neutrons inside of it. Then we also have what we call electrons, and the way that the Bohr diagrams visualize the electrons is through the use of what we call shells. So think of these as shells that surround the nucleus. So this is, and I will try to use another color to help with the labeling. So the center here is the nucleus, and that has the protons and the neutrons inside of them. On these shells is where the electrons lie. And the way that we depict electrons in the Bohr-Rutherford diagrams is through the use of dots. So I will show you that as well. And then we usually sometimes put the electron note, or you can just do the dots on each shell. So again, these are the shells, and those are where the electrons lie. Now, when you look at the periodic table, you see these numbers around each element. Those are the atomic number and the atomic mass. So what do those stand for? So when we're talking about the atomic number, what we're really talking about is the number of protons in the nucleus of that element. And so then what is the atomic mass? The atomic mass is referring to the number of protons plus the number of neutrons. Okay, so that's why you'll always notice that the atomic number is less than the atomic mass most of the time. So let's look at one of these elements as an example. So what is really good is that if you always have your periodic table handy with you, so that when I refer to elements and their atomic number and atomic mass, it would be very easy for you to refer to them. So I'm opening up now my periodic table, and let's do a relatively simple element. So please look in your periodic table for the element lithium. So I'm just going to erase this part so I can show you how calculations are done first. So look for lithium, and lithium is a metal, and it has the symbol Li. Now, if you look at your periodic table, you will see that lithium has an atomic number of, and hopefully you guys can see the atomic number of lithium is 3. Okay, and now let's look for the atomic mass. And usually the atomic mass, if you have difficulty finding it, usually most periodic tables will have a legend that shows you where the atomic mass and atomic number are. So I'm going to show you that. Hopefully I can just pull it up now, and I can show you what it looks like for lithium. So here we go. So for lithium, you will usually see it on your periodic table. So if you look at the box for lithium, you'll have Li. You're told that it's lithium. And then you have your atomic number here. So that's the 3 that we got over here. And then the number down at the bottom, we have, oh, I was picking the one for sodium. It's always good to make sure you pick the right element, as 6.9. Okay, now when you have something like 6.9, to make your calculations a lot easier, you can round it up and make it a 7. So that number at the top here is the atomic number. The number here at the bottom is the atomic mass. Now, what is also really important is to notice that on the periodic table, we don't know how many neutrons are there. But using our calculation that I told you, that the atomic mass is equal to the number of protons plus the number of neutrons, we can use this equation to find out how many neutrons are in lithium. So let's do that calculation on the top here. The atomic mass is equal to the atomic number, which is the number of protons, plus the number of neutrons. So we have our mass as 6.9, and I said that you can now round it to 7. So we have 7 is equal. What is the atomic number of lithium? We said it was 3. Plus the number of neutrons, and that's our unknown. So we don't know how many neutrons there are. Using the wonderful world of math, we can then determine that the number of neutrons in lithium is equal to 7 minus 3, which is equal to 4. Okay? So now we know that lithium has 4 neutrons. You can use this equation for any of the elements in the periodic table. It is universal. So what I'd like you to do now is to try it with another element. So let's pick an element on the other side of the table. Okay? Now it's really good if you try to maybe pause the video after I tell you what element we're going to work on. Try to do the calculation on your own and then see if it is right. So let us look at the element carbon, which all of us are made of. So again, if you look at the periodic table, we have our symbol for carbon, which is a C. We are given the number 6 and 12.01. So again, when you have a number that has the decimal in terms of using the equation, please round. So if you have 12.01, you can use the number 12. So how many neutrons does the element carbon have? If you want, pause the video now, try to do the calculation on your own, and then come back and see if you got it right. So we know the atomic mass is equal to the atomic number plus the number of neutrons. Okay, we know our atomic mass, and that is the number 12. We know our atomic number, and that is the number 6. And our unknown is the number of neutrons. So take 6 to the other side. We have 12 minus 6 equals the number of neutrons. And therefore, we now know that carbon has 6, should have put the number sign, has 6 neutrons. Okay? So again, it is very, very simple equation. All you have to do is remember which number is the atomic number, which one is the atomic mass, plug those numbers into the equation, and you can find the unknown number.